Next, let's look at the second part, the challenges faced by Enterprise WLAN. The first challenge is the diversity of Wi-Fi deployment scenarios. Firstly, there are differences in indoor coverage scenarios. We have many scenarios, such as offices and conference rooms. Some are in supermarkets, which have different requirements. We cannot use the same solution to fit different scenarios. We need different solutions to meet customer needs. The second is high-density venue coverage. High-density venues are very special. In high-density scenarios, the customer flow is very large. For example, venues like stadiums, large auditoriums, exhibition halls, etc. Scenarios with tens of thousands of users pose a significant challenge to network deployment. Wireless networks differ from wired networks. If there are too many people in one place, the network experience can be very poor. So, the planning and installation are quite challenging. The third is IoT integration. IoT integration involves merging Wi-Fi with IoT networks, reducing costs while also bringing some new changes to IoT technology. The fourth is outdoor coverage. For example, in campus scenarios, the requirements for equipment are higher, such as high temperature resistance. In some client locations, summer temperatures can be very high, such as in Dubai, where summer temperatures can reach 48 degrees Celsius. Equipment temperatures might reach around 70 to 80 degrees Celsius. This places very high demands on equipment stability. Normal working temperature recommendations should not exceed 65 degrees Celsius, so this is about high temperature resistance. There are also requirements like waterproofing and sandproofing. The last one is rail transport backhaul and coverage. You might have experienced it. Once a high-speed train enters a tunnel, the signal is lost. At such times, Wi-Fi technology could potentially solve this problem. The second is Wi-Fi technology bottlenecks affecting user experience. First, let's look at the first one. The network signal is good, but you cannot connect to the network. This could be because there are too many terminals, or the network signal is false. Both could be reasons for this issue. The second is that being connected does not guarantee a good experience. Nowadays, everyone watches videos, browses TikTok, streams shows. If there is a high demand for such voice services, it places a burden on the wireless network's bandwidth demand. Some people might use it, and then more and more people connect, and nobody can have a good experience. The third is that while we all have experiences, they are inconsistent. For example, a company might have different campuses. Campus 1 might have a great experience. Campus 2 might be just average. Campus 3 might not be able to use the network well. These are some of the issues we need to address. The third major area is frequently questioned security issues, meaning that many people can easily search for your Wi-Fi signal. For example, you can search for your neighbor's Wi-Fi at home. If you know their password, you can access it. If you are an ordinary person, it might not be a big deal, but if a hacker gains access, they could potentially retrieve some of your information. Therefore, the security of wireless services needs to be seriously considered. The fourth is the complexity of planning and deploying additional Wi-Fi nodes. As our network architecture grows larger, we need more wireless devices. How we deploy different devices, how many devices to buy, how to mitigate interference, how to allocate channels and bandwidth, how many switches to buy, etc. We need to be very clear when planning. The second is the complexity of deploying Wi-Fi, SSID, security authentication, etc. How we deploy them, how to utilize both wired and wireless networks. The third is that monitoring equipment cannot create business optimization. How we optimize the network, what adjustments we need to make after deploying devices in order to enhance user experience, etc. These are issues we need to solve. The last is, when faults occur, how do we locate the fault, such as settings on terminals, wireless interference, identifying where problems occur, whether my device can automatically notify users where the error has occurred. These are some of the challenges faced by Enterprise WLAN. In the last part, we will look at the next generation Enterprise WLAN solutions and the technologies that can meet our customers' needs. First is supporting the 802.111ax standard. If you're building a wireless network now, you definitely go with Wi-Fi 6, since most new smartphones now support Wi-Fi 6 functionality. This is something to keep in mind. The second is wireless air interface technology, which can automatically tune the radio frequency and includes anti-interference technology. Additionally, User QoS, ensuring user experience. Lastly, the mobile experience, with fast roaming and intelligent roaming. The second is security technology, with air protection against attacks, data encryption, and diverse wireless authentication for users, all to ensure the security of user data. The third is network planning, deployment, and maintenance. In network planning, we provide some online tools and software, which can help everyone automatically calculate quantities and plan wireless networks. Lastly, there's IoT integration technology. You can use Bluetooth to connect directly to our wireless devices for configuration and maintenance. Through RFID, Zigbee can also perform some device management functions. This is a solution for the new generation of Wi-Fi technology. Below are some features of the solution. Firstly, full scenario. Different application scenarios have different product solutions. Campus networks and branch networks both have different WLAN deployment and management solutions. The second is high bandwidth. Huawei's Wi-Fi 6 products can already achieve 9.6 Gbps, which other competitors have not yet reached. Also, there's wireless roaming and various technologies such as WMM to ensure service quality. The third is high security. Here are most of the mainstream security authentication and encryption technologies. Additionally, there's wireless intrusion detection, wireless intrusion prevention technology, and through Portal 802.1x technology, users can be authenticated to protect internal network security. The last is easy deployment, which includes multiple deployment methods, supports plug and play, automatic upgrades, autonomous channel selection, etc. Allows some users who are not well versed in WLAN basics to still deploy our network. Integration with the internet can better meet some corporate needs. Additionally, there are specialized products like high-density antenna APs to meet different scenario needs. Lastly, there is support for cloud management, through which we can provide maintenance for some clients who do not have technical staff. This is a feature of our solution: full scenario, high bandwidth, high security, and easy deployment. Now, here is a simple WLAN networking solution. You can see there's an AC, and by adding an iMaster NCE, network management and automated operations can be provided. This is a typical large-scale WLAN networking solution. In this section, we've introduced an overview of WLAN, including an overview of Enterprise WLAN, the challenges faced by Enterprise WLAN, and solutions for the next generation of Enterprise WLAN. Thank you for learning with us. See you next time. Thank you.